For the Khan Academy exercise, differentiability at a point, graphical. All right, so the cases when you can't find the slope, there are three cases when a function is not differentiable. That means you can't find the slope. Wherever the function isn't continuous, wherever the graph of the function has a vertical tangent line, and wherever the graph of the function has a sharp turn. Okay, you want to remember a vertical line has no slope, so that's why there's case 2. All right, so the function g is graphed. The graph has a vertical tangent at x equals -1. Select the x values for which g is not differentiable. That means you cannot find the slope. All right, choose all answers. So let's see. Let's first look at -6 and -3. Those are the x coordinates. All right, on the x-axis, here's -6, and here's -3. At -6, we can see the graph right here. It's pretty flat, okay? It's not vertical. I can definitely find the slope at -6, okay? They want the answers where you cannot find the slope. So -6 is okay. All right, we want the ones, we're not going to choose -6 because we can find the slope at -6. That's just flat. It doesn't break any of the rules in the beginning. Now at -3, you can see it is not continuous, okay? There's a massive jump discontinuity. We cannot find the slope when the graph is discontinuous. So -3 is one that we cannot find the slope of. All right, let's keep going. I put a check on the one where you can find the slope. I put an X on the one where you can't. We're selecting the ones where you can't, okay? Now let's check -2 and -1. X equals. All right, x-axis here. Here's -2. Here's -1. If we go down to the graph at x equals -2 right here, that's perfectly fine, okay? That doesn't break any of the rules. We can find the slope at that point. However, here at -1, if we go to the graph here, that's vertical, okay? We said at the beginning, the vertical line has no slope. All right, so at x equals -1, that's no slope. So we can't find the slope at -1, okay? But at -2, we were okay. All right. Also, remember, they told us in the beginning, the graph has a vertical tangent at x equals -1. Okay, and you can clearly see that right there. So again, I put x's where you can't find the slope. Those are the ones that we're selecting. It's not differentiable. In other words, you can't find the slope at -3 and -1. All right, function f is graphed. Dashed lines are asymptotes. Select the x value for which f is not differentiable. Okay, let's check -3 and 0 for starters. All right. Here's the x-axis. Here's -3. Here's 0. At -3, there is a vertical asymptote, okay? And the graph is vertical. Just like on the last problem. The graph is vertical. We said when it's vertical like that, that's no slope. Okay, also it has an asymptote. So that's at -3. Since it's no slope, I'm going to put an X. At x equals 0, you can see the graph right here. It's pretty flat. We can find the slope of that, no problem. We can find the slope. So at 0, it is differentiable, which means you can find the slope, all right? It's not vertical or anything like that. All right, we did the first two. Let's keep going here and check the next two. We have 1 and +3, +1 and +3. If we go to the x-axis, here's +1, here's +3. So what happens at x equals 1? Well, there's a jump discontinuity, okay? So right here, since there's a discontinuity, you cannot find the slope at x equals 1. And then at 3, look at this sharp turn here, okay? If it radically changes direction like that, you cannot find the slope there either. Okay, so 3 is no good either. All right, if it was like a softer curve, if it was something like that, it would be okay. But when it's a sharp turn like that, that's no good. Okay, so that's at x equals 3. So 0 was the only one where we could find the slope. So we're looking for the ones that we can't. So it's -3, 1, and 3. -3, 1, and 3. All right, G is graph. The vertical tangent is at x equals 4. By the way, as soon as it says that, tangent at x equals 4, you already know that 4 is going to be one of the answers. If it has a vertical tangent, it's not going to be differentiable at x equals 4. So we could just right away just select that one. All right, select the x values for which it's not differentiable. Let's check out -2 and 0. All right, let's go to the x-axis. Here's -2. Here's 0. Look at the graph at x equals -2. It is a sharp turn. Okay, we cannot find a slope at a sharp turn like that. So -2 is going to be one of them where you cannot find the slope. At x equals 0, you're perfectly fine. Okay, it's basically like flat there. You can find the slope there. So x equals 0 is okay. All right. Keep going. And let's go to 2, and I'll show you the vertical at 4, but let's go to 2. All right, here is x equals 2. Here's x equals 4. At x equals 2, what's happening? A very sharp turn, okay? You can't find the slope there. So 2 is another one where you cannot find the slope. And 4, they said it's vertical. All right, and we can see that it's vertical right there. Remember, the vertical line has no slope. All right, horizontal line is okay. The slope is 0, but no slope is no good. All right, so it's just -2, 2, and 4. All right, so just remember, not differentiable. That means you can't find the slope. So again, wherever the function is not continuous, wherever the graph has a vertical tangent line, wherever the graph function has a sharp turn. Those are the 3 cases where you can't find the slope. It's not differentiable.